In this lesson, we are going to look at the nature of stationary points. Okay, so when you have stationary points on a curve, the stationary point can either be a maximum or a minimum. And so in this lesson, we want to show the test that you can use to check whether you have a minimum point or a maximum point. And so this test is known as a d2y dx2 test for maxima and minima. Okay, so the conditions that we have are these are the conditions that we follow. If d2y dx2 is greater than 0 or positive, because if something is greater than 0, it means it's positive, then we have a minimum point at that point. If d2y dx2 is less than 0, then or negative, then we have what is known as a maximum point. Okay, so d2y dx2 is just the second differential. You differentiate something twice. That's when we call it d2y dx2. So here's a question that we have. State the nature of the stationary points on this curve here. Y is equal to 2 over 3x cubed minus x squared. Okay, so the first step that you do is to write the equation. You have y is equal to 2 over 3x cubed minus x squared. Okay, so at this point now, you differentiate this equation that you have, find dy dx. So we are going to have dy dx is equal to, so you multiply 3 times 2 over 3, which will give you 2x, and then you subtract a 1 from the power, 2x squared, minus 2 times negative 1 here, you are going to have negative 2x, and then you subtract a 1 from the power, which will give you 2 minus 1, which is 1. So you are going to have x here. Okay, so this is our differential or derivative, 2x squared minus 2x. Okay, so the second step now is to find the values of x that make this function have a minimum or maximum point. So we are going to equate it to 0 now. We'll equate it to 0 because this is the condition for stationary points to exist. So now we are going to solve for x here. So we have 2x squared minus 2x is equal to 0. Okay, so at this point now, we can factorize this expression here, or this equation. We are going to have 2x, open brackets, x here, minus 1, which is equal to 0. Okay, and then we can solve for x here. We'll get this component which is outside here, 2x is equal to 0, or x minus 1 is equal to 0. So this side on the left side, we divide by 2, both sides. We are going to end up with x is equal to 0, or x is equal to the negative 1, you take it that side, which is positive 1. Okay, so if you want to find the stationary points, you can substitute these two values into the equation given, the original equation. But the question says state the nature here, meaning the question is asking you to state whether these points are minimum or maximum points. So at x is equal to 0, we want to know whether at x is equal to 0, the point will be a maximum or a minimum. So what we are going to do now is we are going to introduce our test, which we can call the litmus test. So our dy dx is equal to 2x squared minus 2x. 2x squared minus 2x, which we found here. 2x squared minus 2x. So now, for us to find d2y dx2, we are going to differentiate this function again. So d2y dx2 will be equal to, and then you multiply this 2 times 2 here, you have 4x minus, you have a 1 here, 1 times 2, you are going to have 2. So you subtract a 1 from there, which will give you 0. X to the power 0 is 1. This is why we just have 2 here. Okay, so this is d2y dx2. We have differentiated our function, the original function, this one twice. You find dy dx, and then the answer you find another dy dx on it, which is we call d2y dx2. So at this stage now, we are now going to substitute these two values that we found one by one. So we are going to say at x is equal to 0, d2y dx2 will be equal to 4. Here where there's x, you replace it with 0. 0 minus 2, which will give us 0. 4 times 0 is 0 minus 2, which will give us negative 2. And so, since d2y dx2 has been found to be negative, according to our condition here, if d2y dx2 is negative, then we have a maximum point. So we are going to conclude and say, therefore, at x is equal to 0, we have a maximum. We have a maximum point. Okay, so at x is equal to 0, we have a maximum point, meaning the curve goes up like this. The curve goes up like this at x is equal to 0. So it's somewhere here, a maximum point. And so now we are going to test also the point at x is equal to 1, so that we find what type of a stationary point we have there. And in most cases, when you have a maximum point at one point, it means the other one will be a minimum point. So let us test the point at x is equal to 1. Okay, so we are going to test it. At x is equal to 1, our d2y dx2 has been found to be 4x minus 2. So we are going to substitute this one where there's x here, which will give us 4 times 1 minus 2, which is 4 minus 2, which will give us positive 2. So d2y dx2 is positive here. So this is a positive number. So therefore, at x is equal to 1, we have a minimum point. So therefore, we have found the nature of the stationary points at x is equal to 0 and x is equal to 1. So at x is equal to 0, we have the maximum point because d2y dx2 is negative. And at x is equal to 1, we have a minimum point because d2y dx2 is positive. And therefore, this now marks the end of our lesson. Thank you very much for paying attention.